So today our session is about array programming. Okay. So where we use this array programming means, first suppose say that if you have to write the same statement for multiple variables, in that case, rather than writing the same statement, like more number of programming steps, we can reduce it by doing the array programming. Okay. So let us take an example for this array programming. First, I'll create the dataset. So here we are going to create a dataset called city temperatures. City temperatures with variable city, which is a character variable, and the other variables like the numeric variables, temp 1, 2, 3, 4, 5, and 6. Okay. Now, so here our main aim is, if you look at the temperature values, temp 1, 2, 3, 4, and 5, and 6, there are some missing data, right? So I want to replace this missing data values with 0. Now, as the traditional programming, how we can do it? I can write like, so tell me, by using if else statement we can do it. So rather than modifying the same data set, I'll create a new one, city temperatures 1. Okay, set from city temperatures. Now, so if I can write if temp 1, okay, equal to missing, then temp 1 equal to 0. Similarly, I can say like if temp 2 equal to missing, then temp 2 equal to 0. So like this, how many variables are there? Same statement I have to write for that many number of variables, right? So rather than doing this, what we can do is we can choose the array programming without writing those many number of statements. Okay. So first, before going into the array programming, first let us know like what is an array. An array is nothing but it is the place where we can store group of elements. Here elements are nothing but variables. So it is the place where we can store group of variables. Okay. As in whatever variables that you store in one particular array, in one particular array, you can represent all that variables with just a single array name, right? And now, when coming to the types of arrays, there are two different types of arrays. One is one-dimensional array and the other one is two-dimensional array. So whatever programs that we write now, we will be writing with one-dimensional array. I'll tell you what is a dimension when I write the array program. Okay. And in the later programming, we'll see what is a two-dimensional array. Now, generally the syntax for writing the array is array. You write like this array and give array name. Any valid SAS name you can give as the array name. Okay. Like, you know the valid SAS names, right? How we define the dataset names and variable names in the same way. Valid array name and then give here whatever variables that you want to store in that particular array, list all that variable names. Okay. So let us do the programming. So same program, okay, rather than writing multiple statements, I'll write the statement only once. Okay. Now, so here I have to do the same kind of statement for all. I have to repeat the same statement for all the 6 variables, right? So first, to store all the 6 variables in one array, I'll give the array name as test. Okay. Array name. What all the variables? These all the variables. Okay. Store temp 1 to temp 6 in this particular array. So which means here you are storing all these variables in this. Now, dimension, right? Dimension is nothing but after the array name in parenthesis, the count of variables that what you are storing in that particular array, that comes as the dimension. Okay. So what is the count of variables? 6 is the count of variables. So all the 6 variables you are storing in this particular array. This is nothing but dimension. Now tell me how many times you have to repeat this particular statement for all the 6 variables, right? As in 6 different number of times. Rather than we writing 6 times the statement, let do loop do that. Generally do block is for that purpose only, right? If you want to execute the same statement for multiple times, you can use do block. So here use do block. Do I equal to 1 to how many times? What is the dimension? 6 number of times. Okay. Do I equal to 1 to 6. Here, now tell me here, rather than we changing this temp1, temp2, temp3 like this, let SAS only do it. Let array do that. Okay. So I have stored this temp1 variable in which array? Test array, right? So represent with test. But at the same time, in the same array, we have so many other variables also, no? Like temp1, 2, 3, 4, 5, 6, like this we have so many variables. Now, how do SAS understand that? We are doing it for temp1. So what is the position of this temp1 variable in the array? First position. Temp2 variable is in second position. So defined by position, like write 1. Okay. So now in this test array, what is the first variable? Temp1. So if temp1 equal to missing, then temp1 equal to 0. Okay. Now, in order to do for temp2, we have to change it here to 2, here also to 2. For doing for temp3, 3 and 3. For fourth variable, 4 and 4. Why we are changing it? Let SAS only do it. Right here, I. Okay. So here I am saying do I equal to 1 to 6, right? So when I equal to 1, test of 1, which is nothing but temp1. When I equal to 2, test of 2, which is nothing but temp2. When I equal to 3, 4, 5, 6. Okay. Now end the do block with end statement. Clear with array programming? Right. Execute. Now we execute this. If you want to print it in output window, print it so that we can view the output very clearly. Raw print data equal to city temperatures 1 and run. See, 0. All the missing values got replaced with 0. If you want to drop this I after the execution, you can drop it by writing drop statement, drop I. Okay, see. Now, and remember one thing, whatever variables that you are storing in one array, all that variables should belong to the same data type, either character data type or numeric data type. Okay. But should not be the mix of both the data types. Remember that condition. Now the next one is, suppose if you want to replace with mean of the existing values, then you just write here as mean. Okay. We learned the numeric functions, no? Use of numeric functions. Mean of the existing variables. Okay. So temp1 to temp6. Anyway, it will exclude from the execution, right? Missing values, anyway, it will exclude from the execution. Remember the condition? When you write mean of, it will calculate the mean only for the available data. For the missing data, it will just leave it. See? Okay. So like this, it will you can replace with the missing data with the mean of the non-missing values, average of non-missing values. Now the next one is we have certain shortcuts for this. Suppose say that temp1 to temp6, same range of variables, right? You can write temp1 to temp6. This also will work out. Else, what are all these variables? Numeric variables. So you can make use of the shortcut numeric underscore numeric. Suppose say that if you want to perform this particular statement, okay, for all the numeric variables that are present in the data set, then instead of listing all the numeric variables, you can just write underscore numeric underscore. This is the generic one. Like when you write this one, whatever numeric variables that you have in the data set, it will consider all the numeric variables. Okay, underscore numeric underscore, and it will do the function for all the numeric variables. Like it will run the same statement for all the numeric variables present in the data set. Okay. Now, the next one is Now when you are writing here underscore numeric underscore, it is not necessary to count like what is the count of numeric variables in the data set, right? So without counting, what you can do is simply write here star. Okay. Automatically it will take the count. Now when you write star here, what is the 6? 6 is nothing but the count of variables, right? How many times that it has to repeat the same statement for the variables. Now, if you don't know that count, then what value you will give here? In that case, you can write dim of star. Dim is nothing but dimension. Okay, dimension of star. Okay, sorry, not dimension of star. Dimension of that particular array test. Okay, dim of test. Now also you'll get the same output. Are you clear with this generic statement like underscore numeric underscore? Okay, now also you'll get the same output. Okay. Now the next one is, let us take, here we are taking the numeric variables, right? All the numeric variables it will consider. Now let us work with character data. For that, let us create one of the data set. I mean like relevant data set. So here I have some data like city season with variable city, season, 2, 3, 4 and rating. Okay. All these are character variables except rating, right? So now what I want to do is I want to replace the character variable data values with NA. Wherever the character variable data values are missing, represent that missing values with NA. Take the same program. Okay. Change, modify the program accordingly. City season. I'll create the same test array only. Okay. Season 1. Right. Now I want to like what are the character variables. So suppose say that wherever the seasons are missing, I just want to replace for that seasons. Okay. Now you write here, suppose say like if you want to like do it for any specific list of variables, then do it for that specific list all that variables here. See here, city value is also missing. Season 1, 2, 3, 4. All these 4 values are also missing. If I want to replace the season 1, 2, 3, 4 missing values with NA, then you write that 4 variable names here. Okay. Because you want to do it for specific list of variables, right? Or you can define the range also because same variables. So you can define the range season 1 to season 4. Now write here how many variables? 4 variables. Okay. So here also you know the count, right? So keep the count. When you know the count, we can write the count. No, if you don't know the count, then you put star. Okay. If test of I equal to, how do you define a character missing value? Blank space and quotations. Test of I equal to NA. Okay. Drop I. Execute the program. See. Okay. It will not replace the city value. It will just do for season 1, 2, 3, 4. But if you want to do for all the character variables, okay. So similarly, it will not do for rating also because rating is a numeric variable and also we didn't specify in the list. If you want to do the same condition for all the character variables, then do underscore character underscore. Okay. Character underscore. And now you can write here, now you don't need to count the list, right? So now you can write here star and here dim of that particular array, dimension of that array. Okay. Now it will do for city also because it will take all the character variables. When you write character underscore, it will take generic, like all the character variables from the city season data set it will take. See, now it is replacing with NA. Okay. Rating it will not touch. And as I told you, like only one data type variables you can put in one particular array. Okay. Now the next one is, suppose say that we have one more special case, underscore all underscore. Okay. If in a particular data set, all the variables are of same data type. Okay, suppose say that here rating is also the character value. Okay, now in this data set, all the variables are character data type, right? In this case, either you can use underscore character underscore or underscore all underscore. Okay, you can use anything. Similarly, if in a data set all are numeric variables, then write underscore numeric underscore or you write underscore all underscore. Okay, both the conditions will work out. When in a data set, if all the variables are of same data type, then you can use this keyword. Okay, or whatever data type they are, you can use that keyword also, like underscore numeric or underscore character underscore. Okay, now run the program. See, now it is doing for rating as well. It will take all the character variables and it will apply that condition. Are you clear with all the three special cases? Underscore numeric, character and all underscore? Yes. Now the next one is underscore temp underscore temporary underscore. Okay. Coming to this underscore temporary underscore, let us take an example. Let us take this data set. Okay. Now here what I want to do is whenever the season 1 is missing, represent with 101, 2 missing 202, 3 missing 303. As in when a specific variable data value is missing, we want to represent with some other value. Okay, from variable to variable we want to differ. In that case, you can make use of underscore temporary underscore. Array programming will remain same. So write here season. Here also it takes city season only. Then we don't need to change. Okay. Now you write here for what all variables, season 1, season 2, season 3 and season 4, right? So define the variables 4. Okay. Now create a temporary variable. Okay. Array. I'll give the array name as temp. You don't need to give as temp. You can give any variable name. How many values? 4 different values. Okay. Now use the special condition underscore temporary underscore. Okay. Now in parenthesis, if season 1 is missing, what value? 101. 2 missing 202, 303, 404, right? Like this we want to assign. Create a temporary variable by temporary array by using underscore temporary underscore. And here what you do is how many times you want to run the same statement? 4 number of times. If is missing, then test of I equal to what is the array name? Temporary array name temp of I. Okay. So write here temp of I. So when I equal to 1, so from here first value and from here first value. Okay, like if season 1 equal to missing, then season 1 equal to 101, right? So that is how it will work. That for that purpose we use this underscore temporary underscore. See, clear with the concept of underscore temporary underscore? Yes. Right. Now the next one is creating. We can also create new variables using the array programming. You know, like till now we didn't create the new variables, right? But we can also create new variables. Let us take the same program. I'll delete the other ones. Just clear up. Okay. Clear this one as well. Now I want to create a new variable. As in say here the temp one is, here the values are in Celsius. Okay, I want to convert this to Fahrenheit temperatures. So the formula to convert to Fahrenheit temperature is Celsius temperature equal to formula equal to 1.8 into, okay, Fahrenheit temperatures, right? So Fahrenheit temperature equal to 1.8 into Celsius plus 32. This is the formula. Okay. So now using this formula for temp 1, create the Fahrenheit temperature. say like temp F1, give the variable name as. For temp 2, create the foreign heat temperature, give the variable name as F3, temp F3, temp F4, F5, F6. Okay, like that you give. So here you write two array statements. How do you write is how many variables? 6 variables. You can also use underscore, numeric underscore, but let us make it bit simple so that it will be easy to understand. And after that, whatever you want to use, you can use it. Now create another array statement for the variables that which you are going to create newly. I'll give us test 1 of how many variables? 6 new variables. And what are the variables? Temp, F1, F2, F3, 4, 5 and 6. Okay, temp F6. So here I am creating two array statements. One is with already existing one is for already existing variables in the data set, and one is for the variables that which we are going to create newly, right? And what is the dimension? 6 times the dimension. If we want to create, what is the formula here? Temp F1 equal to 1.8 into temp 1 plus 32, right? So temp F1 is present in, take this formula. Okay. So temp F1 is present in test 1 array. And what is the position of the variable? First position. But by using this I loop, it will take the position automatically, right? So you can write here temp 1 of test 1 of I equal to C is nothing but temp 1. Temp 1 is present in test array. Okay. Test of I. Right? Similarly, temp 2, 3, 4. For all the 6 variables, automatically when I equal to 1, it will be 1. I equal to 2, it will be 2. Clear? This is how we can create the new set of variables. Execute the program. Check the log. Do I equal to 1 to 6. Temperature, foreign heat, right? So test 1, temp F1 equal to plus 32. And end the do block with the statement drop I and end the program with run statement. What is the mistake that we did? Any semicolon? There is no need of condition, if condition here, right? We are just writing the formula. Why we need if condition? Okay, see? Clear? This is how we can create new set of variables. Hello? Yes. Now, so here in this array, how many numbers we are using? 1, right? So that's the reason we are calling it as one dimensional array. We can also write two arrays, like 2 dimensions we can create. So which is nothing but here if you observe, this is one set of variables, okay, and these are one set of variables, right? So write both of them in the same array, okay, and you write here 2 comma, okay. So which is nothing but here the count is how much? 6, right? 6 is the count. So here what happens is, how many variables did we define here? 12 variables. So out of the 12 variables, here we are saying 6, correct? Which means the first 6 variables it will take as one part, and the next 6 variables it will take as another part. Okay, like the first 6 variables comes in one dimension and the next 6 variables comes in another dimension. Okay, so that is how we are defining the count here, 2 dimensions. Okay. Similarly, 3 dimensions also you can say like, okay, suppose if you have 18 variables, or else if you have here 12 variables, right? So if you write here 3 and 4, then the first 4 variables belong to one dimension, next 4 variables belong to another dimension, and after that following 4 variables belong to another dimension. Okay. So like this, you can create here multiple dimensions. And in each dimension, how many variables, count of variables you can list here. Are you clear with this statement, like this syntax? This 2 is nothing but number of dimensions, and this 6 is nothing but in each dimension how many set of variables. Okay, what count of variables. Now here, since you are writing 2 dimensions and in each dimension 6 variables, the first 6 variables are this. It belongs to one dimension, and the next 6 variables belong to the second dimension. Now what we want to do? Test 1, right? There is no test 1. It is all like test. Okay, test is the only array. Now, what is the formula? Temp F1 equal to, temp F1 is present in second dimension, right? So 2 comma I, okay? And equal to 1.8 into temp 1. Temp 1 is present in first dimension. So 1 comma I, right? So like this you can write. So with single array statement, here you are defining multiple dimensions, 2 dimensions. Okay. Now also you will get the same output. There will be no difference in output. Execute. See, the output will be same. Are you clear with one dimension, difference between one dimension and 2 dimension? Yes. Okay. Right. So this is about array programming. Okay. And tomorrow we'll see correlation and frequency, both the procedures if possible. Okay. Else we'll complete one of the procedure. And from tomorrow we'll start the start procedures. Okay. Okay. Okay then. See you all tomorrow.